So this is a machine learning plus web development project where we are going to build a machine learning model that is going to predict the phishing prediction. That is basically if a site is a phishing site or not. And then we are going to develop a web application on Django where we are going to mount this model and then deploy it on Heroku. So let's see what this project entails. So we have a dataset that contains metadata about 5,000 legitimate and 5,000 phishing sites. So phishing is a type of semantic attack often used to steal user-sensitive information or data, including login credentials and credit card numbers, by masquerading as a trusted entity, enticing a victim into clicking on a link or opening an attachment in an email or through instant messages like using the platforms like Instagram, Facebook, etc. So there is a large data set with many metadata information for which you might have to understand the meaning of the metadata or what does this metadata informs you about before you start working on the dataset itself. So the details of the project. Now, the project is divided into three parts. The first part is building a machine learning model to predict if a site is a phishing site or not. The second is where we build a web application on Django where we're going to mount the prediction model. And the last part where we deploy the Django project on Heroku. So the first part, that is building the machine learning model. So we start off with building a machine learning model where we use a random forest classifier model and train that model using phishing site data points. So there's abundant information, that is the metadata of these sites, which helps us in recognizing the phishing sites. In this particular project, we will learn how to select features and on the basis, I would say on what basis exactly that we are going to select the features is what we are going to see in the machine learning part. Next is Django web application. So this is the second part of the project where we will build the web application using the framework Django. We mount the model we built in the previous part on the Django project here. So this is the last part, right? So this is the last part of the project where we deploy the Django application on Heroku using connections to GitHub. So with this, we can now start off or move on to the first part, that was building the machine learning model. Hi, so this is the machine learning part of the project where we are going to build a machine learning model that predicts if a site is a phishing site or not. So as you can see, the first code block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook. And even here you can see that I am asking that the drive is to be mounted and this directory is to be accessed with it. That is the drive directory. Next, you can see that there are some packages that I am importing, right? So these are not the list of all the packages that I'm going to import, but the list of the packages that might be used in data manipulation, data extraction, data handling, or data visualization. So the first library is the NumPy library. It is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed easily and efficiently. Next is the Pandas library. It is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. So the last two that you are seeing is the Seaborn and the Matplotlib library. So both of these libraries are actually used for data visualization itself, but while Seaborn is a library for making statistical graphics in Python, similar to Matplotlib, Seaborn actually helps in exploration of your data in a easier manner and a more visualizing manner as compared to Matplotlib. The reason being that Seaborn provides you with much more graphs and better color palettes from which you can create better data points, or I would say better key points, right? So as you can see, I am now loading the dataset, that is phishing.csv, from my drive folder, right? And using the function read CSV that is inside the pandas. So using the function head, I'm going to print the first 5 data points of the dataset. I can see that there's ID, num dots, subdomain level, path level, URL length, num dash, and a lot more information, right? Like this is a very large data set. And then you see at the last column is the class label that is defined by 1 and 0, if the site is a phishing site or not. Now I'm first of all dropping the ID column because again it is of no use to me since pandas already creates an ID for us, right? So next is using the shape. I'm determining the cardinality or the dimensionality of my data set, which again tells me that there are 10,000 data points and 49 columns, including the class label. So the next thing that I'm going to do is find out if there is null value present inside my dataset or not. As you can see, I'm using the function isNull, right? And from the name itself, it depicts that we are going to find the null values and along with it, the sum function. So what is happening here is that first, I'm finding if there is a null value present or not, and then I'm finding the sum of all the null values that are present. Meaning, if there's 5 null values present inside my num dots, then isNull is going to provide me with 5 trues, and this sum is actually taking the sum of number of times true is occurring. So basically, what I'm getting is in the end is the number of true values that are present inside the num dots, right? So you can see that all of the values are 0, which is pretty much telling me that there's no null value present inside any of the columns in my data set. So in that case, we can say that yeah, the data is pretty much clean, right? In respect of if there's null value present or not. So next what I'm using is the describe function. Now describe function provides you with a statistical information about your data, and even here as you can see for all the numerical data you can see the count, mean of the columns, right? Standard deviation, minimum, quartile ranges, and then the maximum. You can see that the max is 21, the min is 1, min is 0, max is 14. But here you can see that the minimum is 12 and the maximum is 253. So you can see that the ranges in different columns might be different, and this is one reason why I use the describe function to understand should I be standardizing my data, maybe normalizing some of the columns, because again if your data is too much varied, right, it would create problems in the sense that the model is not able to generalize well on the data and the accuracy decreases. So using the describe function, you can understand if your columns are having too much variance in, not exactly variance, but are too much far apart in their ranges. Another thing to see is that here you can see that the maximum value is 21, right, for the num dots column. Yet the 75 percentile is again showing the value 3, meaning that from the data set, if we go in ascending order, then till we reach the 75 percentile of the data, we are still at the value 3, which means that the maximum is too far from the 75 percentile, or I would say the range of 75 percentile data set to the 100 percentile, has too much increase in the value as compared to the rest part of the data. You can see that the minimum, that is 1. So from 1 it reaches 2, that is 25 percentile of data is again in the range of 1 to 2, and then to 2 to 3, 3, right, 2 to 2 again, not even 3, then 2 to 3 here, and it jumps to 21 till we reach the last of the data set inside the num dots column. So you can see that this is somewhat of a outlier for this column, right? So again, you can even understand if your data set is having outliers in its columns or not. So this is some reasons why describe function is actually useful and why I have actually used this function itself. So next, what we are going to do is find out the categorical data inside our data set. Well, excluding this, because this is a class label, we have to understand the class label also. And as you can see, there are 5,000 class label, sorry, not 5,000. There are two class labels, 1 and 0, both having 5,000 data points, right? As I told you in the introduction also, there are 5,000 legitimate and 5,000 phishing sites. So 5,000 legitimate and 5,000 phishing sites. Next, you can see that from the no HTTPS column. Okay, so what we have done here is that using group by function. The group by is a very essential function if you're trying to find about like more information from your data to infer from your data, right? So if I use the function group by, what happens is that all the data set is now going to be categorized in reference to its class labels, right? So what happens is that now the data set is divided into two parts. Like you can visualize this in this manner. It is not exactly what is happening. That the data set is now divided into two parts where the class label is 0 and where the class label is 1, right? So if I use any function like value counts or some other function for manipulating data, it individually happens, or I would say individually works on the class 0 dataset and class 1 dataset. So as you can see here, first of all, for class 0, as you know, there are 5,000 data points, and in those 5,000 data points, right, so for class label 0, you can see that there is a value of 1 and 0 here. 1 depicting that there were HTTPS and 0 depicting that there were no HTTPS in the URL, right? So here 1, which is phishing site, it is telling me that for 1 that there were HTTPS, there were 4,906 data points where the URL did have HTTPS, and 0 depicting 94 where the URL didn't have the HTTPS inside its URL. So this way we can categorize the data onto some basis using the group by function and then work upon that to understand more of the data. Next is again using the phishing class that was actually categorized into category 0 and 1 on the class label. We are finding the mean in the URL length, and as you can see for class 0, right, which is not the phishing site, the length is greater than the one in which the site is a phishing site, right? Though the difference is not so much, but you can see that here. So in general, you can say that the URL for the site, which is not a phishing site, is of a greater length. Next, again using the num percent mean on that, we can see that the value here are very much different, right? For class 0, which is non-phishing, we can see that the value is 0.1164, which is much larger as compared to its counterpart, right? 0.031. Now again, there are a lot of columns inside this data set that you might not understand. So for that, I would ask you to again go back, maybe search in Google or understand this, right? Because num% is nothing but the number of time percentile character actually comes inside the URL, right? Num ampersand is the number of times ampersand comes inside the URL, right? Sometimes there are URLs like www dot something 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 dot com slash something something and then ampersandile and something something then ampersandile and something something, or maybe a percentile and then 20 and something like that, right? So this is what num% and num and% is telling you. Next again is the number of time hash comes. As you can see, for the non phishing site there is actually no hash inside the URL, but for phishing site there is hash. So you can see that the num hash is a really good indicator as to if the site is a phishing site or not. Then the IP address, and as you can see, there's only one IP address for the class 0, but two IP address classes, right? 0 and 1 again depicts the type of IP address, right? So again, IP address is also indicator that the site might be a phishing site. So with this, we're going to stop here, and in the next part of the machine learning part itself, we are going to understand how to categorize which column is to be selected for our final data set that we are going to fit into the model. We are going to understand one reason or as to one basis on how we were selecting our data set, right, or our columns from our data set, so that we might be able to shrink this data. Because again, if you're directly trying to input 49 48 columns data set into the model, it is going to take a lot of time to train the model. Again, another reason why we cannot do this is because later on when we are building a web application, when we are building a web application, we will need to input this data, right? So who is going to input 48 data points right into the maybe a form or something, right? So that that data is then reaching the backend, and then we are predicting the class if it is a phishing site or not phishing site, right? So that is the reason why we are trying to find out which columns to take in, which columns to be removed, and not directly using the data set as it is, or even using PCA, that is principal component analysis, on this data set to shrink this data set, right? So now what is this? So basically we are building a heat map, right? We are building a heat map, and in that we are sending the first parameter, that is the correlational graph. So what is correlation? Correlation is basically setting up a measure to setting up a measure to understand how much one column is related to another. Meaning, let's say for example, num dots on subdomain level, right? Num dots on subdomain level. So there's a value of 0.51. I know this is kind of small, right? But can't do anything about that. So there is a value of 0.51. Now what does this mean? So this is basically a measure telling that numdots is able to influence the subdomain level to a certain extent, that is shown as 0.51 in the scale of 1 to -1, meaning that if there's a change in num dots, right, value of num dots, there's going to be a change in values of subdomain level also. So this is what I mean when I say that one column is influencing the other column. And the measure of how much influence is occurring is the value here. Now correlation actually ranges between -1 to 1, both inclusive. One being that if there's a change in column 1, there's going to be an equivalent change in column 2 also. And if there's a value of -1, that means that if there's a change in column 1, then an equivalent inverse change is going to happen in column 2. Meaning if num dots and subdomain level had a value of -1, right, as its correlation, then if the num dots was increasing, then the subdomain level would equivalently decrease, right? So this very big graph is with a lot of numbers is actually telling each and every, actually is taking pair of each and every column and finding out the correlation between those columns, right? So why did we actually build this graph, right? This is a big graph, as you can scroll down, scroll down, scroll down, right? So the reason was, what I was finding out is that we have a class, right? We have a class here that is depicting 1 and 0. So from this row itself, I am finding out those columns that have high correlation with class label, meaning that from all of these list of columns, right, except the class label itself, I'm finding out which column has a lot of correlation, maybe positive or negative, doesn't matter. A lot of correlation with the class label, because that means that these columns are able to actually influence my class label, right? So you can see that num dots has a 0.29 value, which is high. And how I'm saying high is because I was looking at all the values here, and the highest value, if I'm taking the absolute value, is 0.54, then 0.46, right? So in that respect, I would say the value of 0.29 is high, but a value of 0.17 is not, right? So you have to understand on your own which value is to be considered, which value is to be removed, right? So I've taken the num dots, then I've taken the num dash, that is minus 0.37, again high value. The values which are closer to -1 and 1 shows that the influence is much larger as compared to a value that is closer to 0, right? So from this I've taken the columns, and now here you can see that using these just columns, I'm able to find out all the columns that are present inside my data set. And here you can see that I'm taking those columns which were actually influencing the class labels. So you can see that the subset phishing variable is now storing a subset of the actual data set, right? And here you can see that there's only 12, right? So 12 columns, and one of them is actually the class label itself. So once we understood that, how to actually select the features from your dataset or the columns from your dataset, you can even take some of the columns that I didn't take, that were like 0.13 value, 0.17 values, right? To maybe increase the dimensionality by a little more, so that you might even get a better accuracy as I am getting, right? So that is totally up to you. You can even remove some of the columns if you deem fit. And next, what I'm doing is again getting my y variable and x variable. That is my target variable and all the feature lists. So here you can see that I'm again importing some of the libraries. That is the random forest classifier, my model itself, train test split function. Again, this function helps me in categorizing my training and testing data, and the accuracy score function, which is again to compute the accuracy, right? So I'm instantiating the random forest classifier model or class, having an estimator that's 250. That means the branches, not exactly branches, but trees that are going to be used. Then the n jobs, which is equal to -1, telling the yeah, like telling the hardware basically that you have to use all the processors to train the model. Now again, I'm using the fit function from the model and the predict function to predict for the test cases. And lastly, finding the accuracy. And you can see the accuracy is 99.81 percentile, which is like very high. And even the testing accuracy is 97.8 percentile, which is again very high. So you can actually see that the features that we chose were the right features because our training and testing accuracy are really very high. So in this way, you were able to build a machine learning model from a data set that was initially having 49, 48 data columns, from which you were able to get a subset that were having only 11 columns, and even that is giving you a very high accuracy, right? So the last part where we actually dump the model using the pickle library. So what we do is we are now saving our model so that later on we are able to use this model inside our web application to do the predictions there. So with this, we have completed the first part, that was building the machine learning project. Second part of the project where we are going to build a web application that would be on the Django framework. So before we start off and understand how to set up the code, how the code is working, first let's understand what Django is. So Django is a Python-based free and open source web framework that follows the model template views architectural system. It is a web framework that has a set of components that helps you to develop websites faster and easier. So this is what Django framework really is. Now, you must be thinking what model, template, views, architectural system is. So basically, we have the front end, the back end, and the database as the main pillars in Django. The template is defined by the front end, basically the HTML files and the static files. The models is defining the tables that are going to be used to store and retrieve the data from, and the views is basically the backend implementation in the apps of the project itself. As you can see on the left side also, our project is defined by the my site directory and our app is defined by the polls directory here. And there's a difference between them. So the project actually helps in maintaining and structuring the Django website itself, and polls in the sense that the apps are actually subparts in the project which provides you with the functionality inside your website. Right, you will maybe understand better when I'm explaining what polls is and what files are being used in polls directory, right? But before that, let's first set up the code. So first you just have to create a project directory. Once you create a project directory, build an environment for that project. So what I mean is that first I just build a project directory which was named Phishing. Then I build an environment. Now if you're using PyCharm like me, you can just go to the files, go to the settings, and inside settings, you will be shown a project interpreter inside the project subpart. I would say the project button. Inside there's a project interpreter. Click on this. You can see there's already a environment set up for this project, but you might not have this, right? It might be empty. So for that, you just click on the settings button, click on add. Then once you click on add, you can just name your environment and where it is going to be stored and which Python version you want to use, right? So once you do that, for your project, an environment will start to load. And once it loads, we move on to the next part, that is to run the pip install command. But before that, what you have to do is go inside the my site directory, right? Here you can see that inside my project directory, I'm inside the my site directory. So once you are inside the my site directory, you can run the command that is install-r requirements.txt. So with this, all the packages and the dependencies that are required by this project will be installed inside the environment itself. So once you have done that, the next thing that you have to do is run the command python manage.py. So this is a command that is specific to Django, not Python. And what this does is that it helps in instantiating all the target models or all the target tables that are required by this Django project. Now, as you might know, or maybe not, Django provides you with the base project, meaning you don't have to build a project from scratch. So if you run the command Django admin start project and then input the name of the project, then a base project is provided to you by Django onto which you can build more apps to define more functionalities onto your website or change the configurations in the settings.py file inside the project directory and run the project in a way that you want, right? So you don't have to build anything from scratch. You can build on top of the base that is provided to you by Django, right? So for the base project to work, there are some required tables that have to be instantiated and used, and for that we have to run this command here. So this is the last command, that is python manage.py run server. So as you can maybe guess, the run server is a command that is to start the server locally onto your machine. So we will be using this once we understand how the project is working. So first of all, let's move to the settings.py file. So here settings.py file inside the project directory, that is the my site directory, and here you can see that allowed host, on which host is this code to be run, installed apps, and you can see that we have created our app polls from ourselves, but there is already some apps specified here which actually comes with the base project. So you can see there is an app that is for authentication, for sessions, for messages. So you can see that there are already pre-built apps that are handling authentication sessions of the website. Next, you can see that there are middlewares also. So you don't have to build middlewares or import middlewares. It is already present here, which is handling the session, handling the security, right? Next is the database. So you can connect your own database to your application from here. So you can connect a Postgres database, maybe a MySQL, SQLite database, right? You can connect those databases and then through the models you can use those database tables. Next, you can see that we have defined static root and static URL. So what are these? So your code or your website will have static files, and static files are actually CSS, JavaScript and images. So to handle those files, we are going to set up static URL that is defining on which path you might access those static files, and static root which is defining in which folder or in which directory all these static files will be present, right? Now there might be something that might confuse you while I was explaining the settings.py file. So for that, if you're still confused, you can just go to the Django docs, and it pretty much is a very easy way to understand how Django is working, since the docs are very good, right? There's even a link, but this link is only for the static files. So moving forward, you can see that we have now just in a way configured this settings file so as to how our project is going to work. Next, what we are going to do is write our code in the polls, that is our app, so that we are able to build the functionality that we want on our website. So first we can go to the views, right? This is the backend implementation where we are storing the data and using that data. But before that, let's first see the HTML page, that is the index.html. This page is actually stored in a templates directory inside the polls directory, right? So as you can see, this is the HTML page with the CSS and all. And here you can see that a form is being created. So we have created a form where we are going to store the values, or actually take in the values from the user itself. And once he has or she has inserted all the values that is required by the project, what we are going to do is ask the user to click on the button, right? The submit button. And once he or she clicks on the button, what happens is that all of that data that was in the all of the data that was in the form is going to be transferred to my backend, that is the views, right? You can see that all that data is now transferred here, and I am storing all of that data into different variables. So what I'm doing is, once the variables are storing the data from my forms, I'm building a data frame, right? I'm building a data frame here, which is going to be input into the phishing model. So as you remember from the last part, in the last code block, we were saving our random model, right? Our model that was the random forest classifier using the pickle library. So here we are loading that same model, right? And using its predict function to predict if the site is a phishing site or not. Since we already have our data, so on this data the prediction is done, right? You can see that the df is now inserted here, and if the value is 1, we understand that the the site is actually a phishing site. If the value is 0, we understand the phishing, sorry, the site is not a phishing site, right? So once we have done that, we're going to return the result using the context. So what happens is that in the backend or in the views, we define a function that takes in the values from forms, right? Then we find out the result using our model, right? The phishing model. And once we get the result, we send back the result again to the front end or our HTML page. So this render function actually helps in rendering the HTML page, which is defined here, that which HTML page is to be rendered, and also helps in returning the response, that is the context, back to the front end, right? So one thing that you might have noticed here is that there is no call for this function. Yes, we have defined the function, we are returning some values, but there is no call for the function. So how is this function being called and used? So for that, we go to the URLs, right? The urls.py, that is again inside the polls directory itself. So what happens is that we set up a path onto which if a user comes, then this index function is being called automatically. That means that there's a URL defined, and once that URL is accessed by a user, this function automatically is called. And once this function is called, then it starts to take in all the values that were filled up in the form, and then we create a data frame, pass it into our model for prediction, get the result, return the result back to the front end. Right. So basically, this is how the application is working. Now, for this project itself, we are only using the template views system. We are not using the models, as we are not trying to insert or save the values indefinitely, right? Which we are getting from the index.html page. So now I'm going to use the last command, that was python manage.py run server, which starts a local server onto my machine, and it performs some system checks and provides you with a URL, that is the localhost URL. So on this URL, I have mapped my index function So you can see that it is now loading the page here, right? So if I type in the name, right, the name of the URL, why there's no specific name of the URL, but you can just insert the URL here itself, which might be www dot something something dot com, right? So there's only two dots present here. Path is 50. I'm just putting in anything, right? I don't know even if the values, since the values are inside the ranges which we were also able to see in our describe function. So we can just put any value, yeah, for just explaining you how the function is working. But just the thing is that you have to input those values which were inside the ranges at least, or else you would be getting a result which might not be true or accurate, right? So once you click on submit after filling up your form, it is going to load the model and do the prediction and return the value. So you can see here that if this is a phishing site, then the value is true, which means that the URL that you had and the values that you presented resulted in a true value for this phishing site. So this is how the Django project is working, right? So with this, we have completed the second part, that was building the web application and understanding the web application and mounting the machine learning model onto the Django application. Right, so in the next part, we will be deploying this application onto Heroku. So this is the third part of the project where we will be deploying our web application on Heroku. So before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start with runtime.txt and procfile. So runtime.txt, as you can see, only stores two values, the language we are using and the version of it. Right? It is basically telling Heroku which language or base is going to be used by the server or should be used by the server. Next is the procfile. So procfile is like the mechanism for declaring what commands and from where are to be run by your application in Heroku platform. The commands that are specified in the last part, like the run server and migrate, these commands are executed in Heroku's server using the procfile. Right? As you can see, I have even given the flag of log file, which tells that whenever the server is starting, you have to log all the activities that is happening in the server. So these files, both of them, are pretty important when you're trying to deploy your application on Heroku. So once you have done that, what you have to do is, again, go to your GitHub account and upload these code onto your account. As you can see, my site, polls, flow, manage.py, requirement.txt, runtime.txt, all of them are deployed on, sorry, not deployed, but uploaded to my GitHub repository that I've named Phishing Predict, right? So once you have done that, right, you can go to your Heroku account. And if you don't have an Heroku account, just create one. It's pretty easy. It asks for your personal information like name, number, email ID. If you're affiliated with any company, right, or if a student, something like that. And once you fill up that, an account is generated for you. So once you log into your account, you will be seeing a dashboard like this, right? So on the top right, you can see that there's a new button which has a create new app. Click on that and then type in your app name, choose the region, there's only two regions there, and then click on create app. Once you do that, then in your personal dashboard, there's going to be the app listed here. So I've already created one, that is phishing websites. So click on that or click on your app, and there would be some options for resources deploy, right? Then go to the settings first, scroll down to the build packs, then click on add build pack, click on Python, and then click on save changes. Once you do that, then the app, this particular app in your Heroku account, will understand that the Python is the language that is going to be used by the server, right? So once you do that, again go back to deploys, and in deploys, click on GitHub Connect. You can see that there are three methods of deployment. First is the Heroku Git, that is like the CLI interface, just like git bash. You can just open your command line or maybe use the interface and code there, or actually put in some commands which will again help in uploading your files to the server, and then you can run commands to start the server. This is the GitHub Connect version, where what you have to do is just connect your repository to this particular app, right? And this is what we are going to use. Container registries for those who know DevOps and understand the cycles for them, so that if they want to automate the process of updating and reinserting, then they can use that. So for this, we have, or I would say I'm using the GitHub Connect. So once you click on this, it will ask you to log in into your using your credentials of the GitHub account. Once you have done that, it would connect your GitHub account with your Heroku account. Next, it would ask you to connect one repository to your app here. So there's going to be a search box where you can search the repository you want to connect. Once you have searched that, there's going to be a connect option. Click on that, then it would show you something like this. Connected to your account slash your repository by your account, right? Then scroll back, or I would say scroll down to manual deploys, and then choose the branch in which your code is present. Since my code is present in master branch, so I'm going to choose master and then click on deploy. So once you do that, your server is now started and your code is now going to be set up on your server. You can see that Heroku Python, that is our build pack, is now actually yeah, is now actually being used by the server, and using the runtime.txt is understanding which version is to be used, right? And then it is now going to start loading and using the requirements.txt to install all the requirements, like the packages and dependencies that we had to use inside our project itself. Then you can see that is running a manage.py command, that is collect static, again to store all the static files in our static files directory, right? Then it is going to compress those files and release your server, meaning you can now launch your server and go onto your site to see if it is working properly or not. So once it has done all of the automated process that it has to do, it is going to give you a views button here, right? Like you can see here, it is going to give you a views button telling that deploying to Heroku is being done. So you can click on views button, and yeah, you can see here that the page is now loaded. Just type in again something. There's no space usually, so keep that in mind. Again, I'm just inputting anything. Well, I say anything, but again, all of these values are pretty much inside the ranges of the columns that we're using to predict the data. And once you click on submit again, okay, this is kind of merging with the background. But again, is it a phishing site? The value is given as false. So the URL that we had and the values that we input tells us that the site is not a phishing site. So with this, we have completed the third part also, that was deploying a web application on Heroku. And with this, we have totally completed our project.